One of the things that we like to say in Erlang is let it crash.
Welcome, Erik. Nice to have you on the podcast. I saw you posting on LinkedIn about some courses you're doing about BEAM, so I'd love to talk to you about BEAM and learn a little bit more about that.
I've been working on the BEAM for a long time.
So for those that don't know, which I think is an awful lot of software engineers, because many people are focused on web development these days, and JavaScript, what is BEAM?
So BEAM is the runtime system for Erlang and Elixir and Gleam and some other languages, but it all started with Erlangs back in the late 80s.
Wow, a lot of people forget that Erlang is actually quite old now. It's a very mature language and ecosystem, but it's never quite hit the popularity that, say, things like Python or JavaScript have. So what makes it different to those?
It's based on concurrency. So it was developed at Ericsson by... Actually, it started in a lab that was both Telia, which was the Swedish telephone company, and Ericsson, the provider of telecom switches and infrastructure. So they had a software lab together, and there they started thinking about, okay, how do we build these telephone switches? Because Ericsson had just started realizing in the late 70s and the early 80s that they were spending more money on software development than on hardware development for the new switches. So they realized that software might be actually important. So then they gathered a team to figure out, okay, so what makes telephone switches special and how do we want them to work and so on. And so they realized that for hardware, they always have two of everything to have the fault tolerance. So the system has to be distributed, and you have to be able to run things in a distributed setting, and you want to have concurrency and isolate faults. So the system is designed from the beginning to be fault tolerant and to be able to handle a lot of transactions and handle a lot of traffic, and very good at doing things that telephone switches does. But it turned out then when internet came that being good at handling telephone switches is also very good at handling internet traffic and handling websites and services and payments and anything that needs to be fault tolerant and secure and fast on the network.
Yeah, absolutely. It's amazing how much great software has come out of software laboratories at telco companies. You know, we had Bell and Lucent producing a lot of software. Obviously, Bell was C, C++, and Unix, and a lot of came out of those. Erlang, a little bit later, but not too much later there by the sounds of it, coming out of the telco laboratories here in Europe. Why is Erlang never quite taken off and received the same sort of uptake that, say, C has? Because you're going back quite a long way there before most people dealt with distributed systems. And as I understand it, Erlang has a lot of great design features, a really well-built platform for concurrency and that distributed fault tolerance. So it's kind of there before everyone started building distributed systems with, say, REST and Python and JavaScript. Had all that facilities for that fault tolerance. So is there a reason why it hasn't really taken off and sort of fulfilled its potential?
Yeah, well, many reasons. One is also the one that usually the best system is not the one that become popular for some reason. But
true.
So Erlang came at about the same time as Java, but Sun spent a lot of effort on actually marketing Java, and Ericsson was keeping Erlang as more of a secret tool. It wasn't released open source until I think in the 2000s or close to that. So it wasn't in the beginning that easy to get hand of if you weren't in a university or something like that. And at the same time, Java was being promoted heavily. Also, it's a functional programming language. With functional programming languages have always been seen as a bit more mathematical and obscure. or academic in many places, and it got its syntax from prologues. People really struggled with the syntax for some reasons. There were a couple of reasons, I think, that it really didn't take off in the same way as Java at that time and other languages after it. But yeah, Elixir has done a little bit on the syntax side, and there are other languages coming now. So the real thing is really the BEAM and the way that processes are handled on the BEAM.
Okay, cool. Let's talk about that in a moment. But yeah, I can see that. I hated Prolog when I studied at the university. Was never a big fan, so that would be enough to put me off if that was my first thing I learned about it. And you're right, I can remember back in 1995 to about 1998, Sun was... You couldn't move without Sun pushing Java and talking about how it was going to almost cure world hunger and bring about world peace. It was the answer to everything. And there seemed to be new libraries all the time and so much marketing for Java. It was absolutely crazy. So on BEAM and the way that it handles processes, what is different there? What's the unique element that BEAM and Erlang and the ecosystem brings to?
So it's, of course, the processes, and they are truly lightweight processes, so much lighter than most thread libraries. The default process starts with a very small stack and has only a small process control block, so a couple of hundreds of bytes instead of kilobytes for each process. And each process has its own stack and heap, so it can do garbage collection by itself. So you don't have any stop the world garbage collection, and that you can see in Java. And also there's no shared memory between processes, so all communication between processes is through message passing, so you send messages between the processes. Of course, in the background in the BEAM there's some shared memory and a lot of things happening to copy these messages and so on, but for the user and for all the processes it's looks like no shared memory, and there's no way for one process to interfere with things in another process. So this makes a whole lot of problems easy to reason. It doesn't take away all the problems. You can still do deadlocks and so on. So you have to build architecture on top of this, and there's a lot of architecture in OTP. It's called the Open Telecom Platform, giving you some abstractions on top of this. But then you also should bring your own, which is things I talk about in my essays about the GNOME village, which we can talk a little bit more about later. But how to structure your programs on this on the BEAM.
Cool. So you mentioned lightweight processes and lightweight threads. They've got a very low overhead. And as you mentioned that, I'm thinking about Go, which has recently become popular, that again focuses on that lightweight threads with Go routines and message passing using channels. Has Go borrowed a lot of that idea from the same, or from Erlang, or from the same sort of place as Erlang?
Probably same sort of place. Go has a slightly different model, and I have never really managed to wrap my head around it. So I think the BEAM model is very easy to understand, and it makes for sort of, in my experience, more readable code and more easy to understand code. But Go definitely comes from the same source of thinking about how to break programs up into processes and let them communicate.
So whereabouts is BEAM being used in? Obviously Telco was an early start for Erlang and the OTP. As you say, that's expanded now into telco and the internet, but I think it's much more, not quite as widely used maybe as Java and JavaScript and Python and those, but much more widely used now than perhaps it was in the late 90s. So who else is using it? What sort of markets? What sort of technical challenges are they tackling?
So still the telco, some people say that 95% of all internet traffic is touched by Erlang some way or another, because Cisco and Ericsson are using Erlang for a lot of stuff on the way in the hardware layer and just above the hardware layers there. So, but we have other big companies like WhatsApp was built in Erlang. So the whole back end of WhatsApp was just a few engineers that built the whole thing, and it's handling billions of messages per day. Did that already many years ago.
Yeah, that was a great case study for it.
Klarna, where I was CTO back in days was also built in Erlang and is still the core services in Erlang. We have a Swedish company called Kivra that does post your digital post box, and almost all governmental messages like tax returns and so on are sent out to this. So almost all Swedes use this system. And there's a lot of other Bet365 betting company. There's gaming companies. So a lot of companies that handles high volume traffic. I built a blockchain in Erlang once, and also so there's a lot of places you can use it.
Yeah, I imagine any distributed system that you want fault tolerant is a great approach for that. One of the great articles I read, must be about 10 years ago now, was somebody in the Linux community, I think, discovering this idea of crash first software. So don't build your software to shut down cleanly, just accept it could crash, could get killed, whatever, at any point. So try and be stateless, and that makes for software that can recover very easily because there's no state. But I think even then that idea was borrowed from Erlang, is that right?
So one of the things that we like to say in Erlang is let it crash. So there's a really well thought out handling of errors and escalations of errors and failures in Erlang. So you have throw catch mechanisms, but you have, even more importantly, you have signals between processes. So messages is basically one type of signal where you explicitly send the message to another process. But a process being spawned and a process dying are also sending signals to processes. And you can then create these monitor processes that spawn a process and then watch them. And if the process goes down, it can restart it. So you have supervisors in Erlang. And there's with OTP the supervisor pattern where you can build up hierarchies of supervisors. So if a process encounters an error, there's a message going up the stack first, and you can catch it and handle it if you in the code understand what the problem is, or if it's something that should be a normal error and you should handle it. But you can also just let it propagate all the way to the top of the process stack, and then the process will die and send a signal to its supervisor, and then the supervisor can restart your process. So this makes the code very nice and simple, because you can most often focus on the happy path and make sure that you handle things the right way. And if some obscure error case crops up, you can crash and restart, and of course log things and then figure out why did this happen. Is that something we should handle somewhere else, or should we handle it here, and so on.
So that architecture you described is fairly common in a lot of distributed systems, but a lot of people will build it as there'll be a process that's doing the work, another process that's monitoring it. And when I say process, I mean operating system process. Particularly one of the advantages of building those with different operating processes is that when a process dies, it doesn't impact anything else. There's no blast radius, and another process can restart it. If all these processes are running within BEAM, how much isolation, how much protection is there? Because it sounds like you're in a lot of that infrastructure that we traditionally build, as a software engineer ourselves, kind of batteries included or built into BEAM. But how much protection is there so that one process is not going to kill one BEAM process is not going to kill another BEAM process, or take down all of them that are running in there, versus that isolation you have with a operating system process?
Yeah, so it's basically the same isolation as an operating system process. So compared to a thread and shared memory, an Erlang process, even if we call it the process, so it's more like an operating system process, not a thread, even though it's very thin and doesn't use much space. It cannot is a hard word, but it doesn't affect other processes. Of course, you can still do stupid things from one process that can, like halting the system or something like that, but that's in the normal sense you will not affect any other process. So, but you still have things like deadlock, of course. So if two processes for some reason want to talk to each other and get into a state where they send messages to each other and waiting for each other's messages, you can create deadlocks and so on. There's no simple way out of that. But if one process dies, it doesn't matter. But you can also choose when you set up your supervisor, you might set up a number of workers that are slightly dependent on each other. And if one of them crashes, you can decide that, okay, then we should kill all the processes and restart all of them because they were anyway dependent on each other. So we need to do all the work from scratch. So these are restart policies that you decide when you start up your supervision trees.
Okay, so I'm a little bit curious now. How is BEAM providing all that isolation? Because obviously there's a lot of work gone into your operating system to provide that isolation and to create the virtual memory for a process and make sure each process is isolated and can't impact another one. Is BEAM reproducing that, or is it addressing some other way, or is it leveraging the operating system for that?
Oh, it's basically reproducing that. So processes only work within its own stack and heap and mailbox and process control block. And in Erlang code, you cannot address memory directly. So there's no memory. You only have terms that you pass around, and so there's no way for your program to start talking about memory and doing strange stuff.
So long as there's no bug in BEAM, you've avoided an awful lot of issues there. So given BEAM and Erlang are designed to be very, very fault tolerant, how well tested is BEAM? Is there a very formal specification that's holding it together and a comprehensive test suite?
So there's no real formal specification. There's not really even any language specification for Erlang, but there are some attempts, but it's extremely well tested by now. So it's been used at Ericsson since end of the 80s, or at least beginning of 90s in real products. And for example, the AXE 301 switch that they built in the beginning of the 90s were running in Britain telecom system, and after I think 5 years, the British Telecom reported 9 nines uptime of that system.
Nice.
Then, of course, you have the multiple hardware in those systems also, but that's a pretty impressive thing. And I know for a fact that there were a lot of bugs still in there then, but it still kept that uptime.
I've heard great things about the reliability of the platform. I was just really wondering, technology has moved on, the hardware has moved on. Even if you don't necessarily need to upgrade the hardware, people stop making old chips. So, as you progress through internet switches and they get bigger and more capable, probably the CPU that is in the internet switch is going to change. Somebody's going to need to port it. So keeping that reliability as you move through that change sounds like quite a lot of work. I was wondering how that was tackled, really.
So it's the runtime system is implemented in C, and it's been ported to almost everything. And it's just you can run it from small gumstick computers I have a Raspberry Pi here in my lab. So from anything really small to my big box here with 20 cores, or even bigger systems. We had at Klarna, we had machines with 2 terabyte of memory and 80 cores, and Erlang can handle and the BEAM can handle all of these different types of hardware with no problem.
So we talked a lot about everything it's providing. A lot of those things often come at a cost. But in telco and internet switching, we want fairly low latency. So how does the performance look? How do those guarantees and that safety affect the performance? So
there's, of course, a little bit of performance gap between Erlang and code, but nowadays there's a just-in-time compiler also, and I wrote the first native code compiler for Erlang back in when was that? 96.
That must be ahead of Java.
Maybe at the same time or something like that. But so you have had that possibility. What I discovered in my PhD thesis was that I could speed up programs from the emulated BEAM, or there was also a jam a machine before the Beam that was a bit slower, 10, 20, 100 times in benchmarks. But as soon as you got to some of the real programs, all the latency was in network and databases and other things. And
always the way.
The performance gain of pure Erlang code was not that important in most cases. But the handling of sockets and binaries that we have in Erlang, which is blobs of bytes or that you can pass around in the system, is pretty efficient. So binaries live outside the process heaps and you just pass pointers to them. So for network traffic messages in, for example, WhatsApp or something like that, you can often just pass these pointers around, and this is pretty efficient. So it's sort of optimized for throughput for a couple of things, and it can then very easily, there's a bit syntax in Erlang, so you can write protocol parsers very, very nice in Erlang with very nice code. So sort of match the protocol specification basically from the text straight off. So yeah, it's not as efficient as you can get perhaps with pure machine code or pure C code or Rust nowadays, but with native code compilation and just-in-time compilation, you're pretty close in most cases. And basically, for all practical reasons, it's good enough, and you get the robustness with a little bit of price, and that's in most cases worth a lot more.
Yeah, absolutely. We too often underestimate how important reliability and robust software is versus outside of a few things like high-frequency trading, you really don't need that last few nanoseconds. So I also noticed you have a book coming out soon, Erlang by Doing. I'd love to hear more about that, because I'm a great believer in people should learn by doing, so great to hear about it.
So one thing is that since the last Erlang book came out was a pretty long time, so we have a lot of things now in the language that we didn't have 10 years ago. So we have maps, and there's the language has evolved, and most books recently have been on Elixir. It's time for a new Erlang book just to get the latest syntax in there. But I also think there's also a lack of a book that teaches a little bit more about how to think with processes. And there I have my gnomes. So I imagine the Beam as a village of gnomes. So I see all the processes as little gnomes. They are completely independent of each other. And then you have a scheduler. So there's you can see this distinction between parallelism and concurrency. So there's only a few gnomes that can be working at the same time. That's as many cores as you have in your system. But so we have workbenches where the gnomes do their work, and then we have a scheduler that says when it's time for the next gnome to do a little bit of work and so on. So but if you have 4 cores, then you have 4 workbenches, and you can do 4 times the work at the same time. And you can also have supervisor gnomes and so on that handle how things are. And one gnome cannot look into the head of another gnome or change anything in that gnome's memory. So the only way is to send a message between the gnomes. So I build a whole explanation of how things work with this. And then I have some ideas about how to break things up into domains and also think about flows in your system. So that's what I'm aiming to cover in the book. And the how is by having a couple of projects like a game and so on that we build from small concepts all the way up to more and more concepts. And you can learn by doing this in the book with examples and trying things by yourself.
I love that. My whole thing is to get people to learn by doing, so I encourage people to build a full working software system, to learn a programming language or learn a technique or learn how to use a cloud platform or whatever it is. I haven't heard of Erlang being used for a game before. That sounds a bit different. What's that like?
There are a couple of companies that have used Erlang for games for many years, and there's still a lot of them around. And at Happy Hacking, we made Taba, which is a small puzzle game. On my spare time, I'm also doing a big space game right now. It's definitely doable. And today, it's the machines are so fast, so I can even do canvas rendering in Erlang that I send to a browser for the game, and it's fast enough.
I was going to ask about that because I was going to say, can you imagine it being perfect for the big, massive multiplayer online games to build the back-end server and to coordinate the world and coordinate all thousands of players being online? But I wasn't sure about rendering the graphics and outputting that. So
yeah, so there are a couple of those big. There is a big space game that uses Erlang in the backend for that.
Are there any other projects you can talk about in the book as well as a game?
So I have not exactly decided yet on which projects I'm going to include. I have so many interesting ones, but it will probably be something fintech like also.
Fintech, okay, interesting. Am I right in thinking, I want to look this up, but I think, is it RabbitMQ? It's built on Erlang?
RabbitMQ is built in Erlang, yes.
Cool, so it's probably a really good fit for something like that then. Okay, so we mentioned Elixir and Gleam and Erlang. They're all building on Erlang, OTP and BEAM. How are they all different? I mean, you mentioned that Erlang was Prolog, and you put me off a little bit there. And the functional's cool, I like that. And functional seemed to have a rise in popularity, I want to say about 2008 to sort of 2018 maybe, and that maybe the excitement of functional seems to have died down a bit recently. But what's the difference between Gleam, Erlang and Elixir? What do they each bring to the party?
So Elixir, first of all, came from a Ruby programmer, so a lot of thinking from Ruby introduced and focusing on the syntax, and it brought in pipes, so you can pipe your functions instead of in Erlang you have to. Well, usually your functions take many arguments and might return even tuples with many arguments and so on, and then you stitch them together yourself. But in many cases, you want to have one data structure that you pass through a lot of different things. Elixir has a nice pipe syntax for this. And the thing I don't like about Elixir is that it's making it too easy to overload things and make your own domain-specific language. It has a very powerful macro system. So I used to like these kind of things a lot when I was young and didn't have to read code. Once you actually work with code and you have to read other people's code, you realize that the less people can come up with their own syntax, the better. So Erlang is very simple, and you can always go into any file and understand what it's doing. So I worked on Scala on my postdoc, so that language had everything, and you could really redefine every operator and so on. And it even had a way of, by using colon, you get left associative operators instead of right associative operators to do append and things like this, or cons instead of append and so on. But yeah, I think that's basically a very bad idea. So because you read code a lot more than you write it. So I'm trying to stay away from Elixir, but there are so many good libraries in Elixir, and especially if you've been working in embedded systems and so on, there's a lot of stuff, and also a lot of stuff for AI. So I'm doing more and more Elixir these days. Gleam adds static typing, so both Erlang and the Elixir are dynamically typed. Elixir is working on a type system, a static type system now, but it's very early. Gleam has this, and Gleam can compile both to Erlang and to JavaScript. So you can run the same code in the browser as in the backend, basically. But of course, depending on your target, you're getting different types of functionality from the target. So you can't do everything everywhere, but to some extent you can use it in both worlds.
Cool. That's really interesting. I've played with Gleam, I mentioned just before, for about 2 days, and I've got on my bucket list to look at Elixir sometime, but again, you've put me off slightly. I'm like you. When I first discovered C++ and operator overloading and overloading functions, it was great. I can do all these things. Then after a little while, it's like, I'm fed up. What does this operator actually do for this class? And I got to really appreciate Go in that there's no overload, unless there's no ability to kind of overload that and confuse it. They do what they say on the tin. So I'm definitely coming back to after years of doing this, to keep it simple. Don't allow us to change everything. And I'd rather have more verbose but simple code that does exactly what it says. So we talked a lot about the processes and message passing. Are these the thing that you think makes Erlang scale the way it does, or is there something else that's really special about Erlang that makes it scale so well?
So it's the lightweight processes, definitely, and the isolation that you get in them. So that's the big thing, and of course some of the OTP things that you have on top of it that makes it easy to do the supervisors and handling the failures and so on.
So if somebody wanted to go away and learn the ecosystem, how would you suggest they start, and which should they focus on? Gleam, Elixir, Erlang?
So Elixir and I think also Gleam now have very big communities and a lot of helpful people and a lot of helpful sites. Erlang not so much. So it's a bit like the secret telecom technology. You have to really go looking for it. There's information. There's a good book, Learn You Some Erlang for Greater Good by Fred Herbe, and that's a good start. So, and if you want to learn about thinking on this, you can go to my blog and read the Gnome Village post and related posts.
Yeah, I think that's well worth it, because even if you don't use Erlang, thinking about some of these ways of modeling your systems is a good way to build distributed systems in any language, isn't it? Cool. And then, so let's say you've gone away, you've learned Elixir or Gleam or Erlang, and you're interested in adopting it in your company, you think it's a good technology to build on. What are the things that somebody should think about before they adopt it and start building out a production system in it?
Good question. Yeah, so it doesn't solve everything, of course. So you have to still have a good idea about your architecture and how you're going to build it. But if you do that, it will take you there much faster and much easier than most other programming languages.
Are there any particular lessons then that you've learned from learning BEAM in production that are a hard one that you'd like to share that people should avoid?
So Erlang has a really nice feature called hot code loading. So you can load a new module into a running system, and this means that you can very quickly upgrade things. But the thing is, you have to really think before you do that, because upgrading the code, still the data structures that you're passing around will not get upgraded. So there's tooling in OTP to do this. If you're using a gen server, you can have a special upgrade function. So it will be called and you with the old data and return the new data structure for things. But still, you have to think a lot about this. So nowadays, I think most people with Dockers and so on, you just roll out a whole new Docker and upgrade your whole system, even if it takes a few minutes. It's usually not a big problem with blue-green upgrades and so on. So you can solve this in other ways nowadays, like and enjoy and use in most of my system hot code upgrades, and think it's good, but you really need to think about it a little bit before you do it. Still, you have the same problem on a higher level doing it with upgrading whole Docker, because you usually nowadays you have a database in the background and you have messages to microservices and APIs and so on, and you have just pushed this problem to some other interfaces, and you still need to think about what I'm doing with old data and new data and so on. So
it's always a way, isn't it?
Long-running systems, this is a real problem.
Yeah, we still have to think no matter what, no matter how great the technology is. That's awesome. That's been a really interesting look. Is there anything else, Eric, that we should have talked about the whole BEAM, Erlang, Elixir, Gleam ecosystem?
So also Erlang is designed to have very nice introspection from the beginning. So it's really, these systems are supposed to be running, and you should be able to go into them and see what's happening. And if you're allowed to do that, which I hope all companies allow you to do as an engineer, you have to just see how you handle your processes around GDPR and other things. But this is completely possible. If you're allowed to do this, it's such a enormous boost when you're debugging. So you can go into the running system and you can see the messages that are being passed between processes and what's on the stack of processes and so on. And you can really find the root cause of most problems pretty quickly when you can do this. So that's different from a C system, for example. It's impossible to see what's inside. But with Erlang, you always have a shell and a REPL. And since all the data types are well defined and tagged on you can actually see what kind of data, what data it is anywhere in the system.
That sounds incredibly powerful. I think I might have to go and get your book and start learning to build a game in Erlang. It sounds a lot of fun. All right, great. Thanks so much, Eric. I really appreciate you taking the time to come on the podcast today. If anybody wants to follow up and talk to you, and I believe you're teaching a course in Tenerife, did I remember that right? Somewhere nice. Malaga, sorry.
Malaga, yes. On the 22nd of April, so...
Right, so if anyone's got budget to learn about it somewhere lovely and sunny, they should reach out to you, get in touch. All right, awesome. We'll put links to your website and LinkedIn and anything else in the show notes that you'd like to send us, but what's the best way for somebody to get in touch?
Yeah, it's through my company website. It's happyhacking.com, and you can probably find me on LinkedIn.
All right, awesome. Thank you very much, Eric. It's been a pleasure.
Thank you.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.